Welcome to the Insightful Professor. In this lecture, we continue our examination of user-defined types in the Oracle database world. Previously, we discussed structure and identity. In this video, we'll pick up and talk about behavior. In practice, what we see is that objects consist of both structure, data, and behavior, which is process or functionality. In examining object behavior, we'll consider integrity. When an object is stored in an object-relational database, it's stored in a table. Integrity can be defined through mechanisms associated with the table, such as declarative integrity and procedural integrity. If we wish to consider a more general view of integrity, we're going to have to consider how objects can be instantiated, even if they're not made persistent. That is, we could create an object stored in a database, or we could create an object in working storage as a variable. The program terminates, that object goes away. But if we wish to enforce integrity consistently, we'll have to look at something beyond the integrity constraint mechanisms associated with database tables. So that's something we'll address in this lecture. The create type statement defines the structure and announces methods for an object type. The create type body statement implements the behavior of an object type by supplying the code or instructions for these methods. For an object type with behavior, the create type statement includes forward declarations or signatures of methods for the type. This is what we mean by announcing the methods. A method signature consists of the method's name and the number, types, and the order of the method's formal parameters, including the implicit self parameter. An object type may have the following methods. A constructor method. This is invoked to instantiate an object. Remember that while object-oriented software environments tend to use the term constructor, Oracle Database refers to this as a method. Comparison method. An object type can have a comparison method defined, which is used to compare objects of that type. Member methods. These implement programmer-defined behavior of the object types. A static method is invoked on the type rather than an instance of that type, rather than on an object. Now, every method identified in the create type statement must have an implementation defined by the create type body statement. The methods identified in the create type statement define the interface to the objects of the type, how we communicate or interact with them. A constructor method is created automatically by the system when a type is created. If an object type is defined entirely with the create type statement, that is, the type has structure but no behavior, the type has a system-defined constructor. This is an attribute value constructor that is created automatically by the system. When invoking this constructor, you must provide a value for each attribute when instantiating an object. For a type with no behavior, integrity is not part of the type or object, but must be enforced where the object is used. For persistent objects, integrity constraints can be defined for the table that stores the objects. For persistent object or temporary objects, integrity can be enforced through application logic. The constructor method is always a function. The name of this method is the same as the name of the object type, and this method returns an instance of the associated object type. The arguments to this function correspond to the attributes of the type in the same order as they are specified within the type definition. The system-defined constructor cannot be modified. Now, we can have one or more user-defined constructors, exploiting this concept of overloading. To achieve overloading, the parameters must differ in order, number, or data type. The system-defined constructor is called the attribute value constructor. It requires a value for each attribute of the type, and the constructor sets the attributes of the object being instantiated to the values provided. There's no validation of these values. That is, if the data type is a number, it simply accepts a number, positive, negative, outside of what you might consider an acceptable range. If it's a number, it qualifies. Here's an example where we create the type address as an object, and we have 4 attributes: street, city, state, zip code. They're all characters. At the bottom, we show the invoking of this constructor. Remember that the name of the type is address. The name of the constructor function or method is also address. So street receives a value of 100 Main. City receives a value of my town. State receives a value of CT, and zip code a value of 12345. The values are supplied for the attributes using what we refer to as a positional notation. This means that the first value supplied to the constructor will be assigned to the first attribute of the type, the second value to the second attribute, and so on, based on the position or order established for these attributes when the type was created. This ordering can be determined from a query of the metadata for the type or by using the SQL+ describe command to access metadata. Values can also be supplied to the constructor using what is called named notation. Each attribute will be associated with a value. The equal greater than is the association operator. Observe that by using the name notation with the association operator, you're given a little bit more flexibility. The attributes can be supplied values in any order. A comparison method is an optional user-defined function that is automatically used by the system to compare instances of the same object type. Note that it is optional. You do not have to have a comparison method, but by not having one, you limit the capabilities of the system with respect to doing comparisons. A comparison method can be explicitly invoked. It is a method, it's assigned a name, but its intention is really to be invoked automatically by the system when there's a need to perform a comparison. If no comparison method is defined, then objects of the same type have limited capabilities for being compared. The system can only determine if 2 objects or 2 instances are equal to one another. They cannot be ordered. So instances would be considered equal if each pair of corresponding attributes is equal, if they have the same value. So if we create a comparison method, we have a choice. Obviously, we can go without one, but we could have a map method or an order method. But we can have only a map method or an order method. We cannot have both types. Member methods. A member method is a user-defined routine to implement some aspect of the object's behavior. These methods could be defined as either a function or procedure. We can have multiple methods for an object type to implement whatever behavior we realize is necessary. Methods of the same kind, function or procedure, can be overloaded, provided that there's a difference in the formal parameters or the signatures of these routines. When we invoke a method through SQL, if the method has no arguments, we must still provide parentheses. When we invoke a method through PLSQL, if the method does not have arguments, we can use parentheses, but we're not obligated to do so. How do we declare methods? Well, methods are specified as part of the declaration of the type. Remember, I had indicated that the create type statement includes a forward declaration or an announcement of the method. We introduce effectively the signature. Within the create type body statement, we provide the implementation of the method. This approach follows the idea of an abstract data type, or an ADT. All that is needed to use a method is knowledge of its signature, that is, how it should be invoked. With this approach, the implementation details are clearly separate from the design of the object's interface. No knowledge of the implementation details are required to use the object and invoke its method. This is consistent with what is taught in a computer science course in data structures. Here's an example of creating an object type called address. We've looked at this in the previous video, but now what we're adding is a declaration of the methods. We'll have a member method, a function called getCity. The intention is to return a character string, which is the value of city for the current object. We'll have a map method. This is one of the comparison methods that we briefly mentioned. We call it compare. The name is really not that important, because if we're designing this for purposes of the system being able to use it when we do some kind of an operation to compare two instances of an object, we're giving a name just to satisfy a requirement that the method have a name. We really don't want to explicitly invoke this, that is, use its name to make a call to the function. That's possible, but it may not be as practical. Once we've created the type, there's additional metadata recorded in the system catalog. We can access this through the SQL+ describe command, or we can run a query. Recall that if we're using Oracle Live SQL, the SQL+ describe command does not work. So I'll show you an alternative method to access some of this information. If we say describe address, it indicates the structure, but then it goes on and lists the methods that have been declared. Notice at this point, all I've done is execute the create type statement, not the create type body. So we've announced that these methods will be there, and the system has recorded what these signatures are. But if we were to try to instantiate an object at this point, we have nothing behind the object. That is, we've not created the body, therefore getCity can't do anything yet, nor can compare do anything. But the metadata has been captured. The information we see in the describe command comes from different catalog views or tables. User type methods is one of these. This contains descriptions of the user's types. We have the name of the type, the name of the method number, so that if we have multiple instances with the same name, overloaded methods, the system can make a distinction here. The method type, remember that this could be a procedure or a function, and then some characteristics of this. How many parameters does it have? The number of results returned by the method. Is it final? Is it instantiable? These values here will be of interest to us when we start to look at inheritance. Note that we're referring to user type methods here. This refers to object types and the methods for these types owned by the current user. I'll be using views that have this user prefix because I'm just trying to get you acquainted with the architecture here. But keep in mind that you may not be the owner of a type that you're using. Someone else may have created it and given you permission to use it. In that case, looking at these user views, you'll not find any information about the type. There's a second level of views, prefixed with the word all. All type methods exist, and this one goes a step beyond what we're showing here. It has an additional column called owner, which is defining the owner of the type. So all type methods describes the methods of the object types that are accessible to the current user. Here's an alternative to using the describe command to obtain some of the metadata. Here we're running a query against user type methods, and we've extracted a few of the columns. So notice we have a method named getCity. It's public. The parameters, well, there's one parameter, one result, and so on. And compare is a map method. What's interesting to note here is that there is one parameter for each method. But if we go back and look at the descriptions of these methods, we didn't declare any parameters for the methods. Why is there one? Observe also that the system-defined constructor does not appear in the list of the methods, either here or in the output of the describe command. Let's get back to the number of parameters. There's a special parameter called self. The self parameter is associated with a member method automatically. This is a built-in parameter that the system uses to associate or access the current object, the invoking object, the object that's providing the context. Self is passed implicitly or explicitly. It's always the first parameter passed to the method. It denotes the object from which the method was invoked, and the data type is that of the object type. So in the case of address, self is an address. If this is implicitly declared, its parameter mode depends on the type of the member method. If it's a function, then self is designated as in. If it's a procedure, then self is designated as in out. Note that you don't have to use self to qualify references to attributes, but it can be helpful. A little bit more of the metadata. User method params. This contains descriptions of the method parameters for the user types. So here we're showing the name of the type, the name of the method. We're also showing the name of the parameter, the number. This is important for positional notation. The parameter mode, in or in out, for example. Then we also have the parameter type name and the owner of that type. Param type owner is meaningful if param type name is an object type or user-defined type. Remember that types are schema objects. There's a concept of ownership that applies here. If the type of the parameter is a built-in type, the value of param type owner will be the null value. Here's a query against user method params. And now we solve that mystery of a parameter count of 1. What we see is self has been declared as a parameter both in getCity and compare. User method results contains descriptions of the method results of the user types. What kind of thing is being returned? The information here is similar to what we've seen in the other table. Quick little query against user method results, and we see that getCity returns a var char2. Compare returns a char. Both are primitive or built-in data types, so notice that the result type name column appears to be void. There's actually a null value in there for each of these rows. One use for a static method is to provide a form of a user-defined constructor. The Object support within Oracle database was introduced back in version 8.0. Shortly after that, Oracle 8i came out. In Oracle 8i, object capabilities within the Oracle database were still somewhat immature. They were evolving. At that time, a static method was the only alternative to the system-generated constructor. So we'll give you a little bit of an idea of how this would work. So in this statement, we're introducing a function that we designate as being static. It's called makeAddress. Notice the 4 arguments of the function. They're the same as the 4 attributes of the type. And notice the return type of the function. It will return an address object. So here we see the static function called makeAddress, and again the arguments agree with the attributes of the type, and the output is again an address object. If we examine some of the metadata, we'll see that makeAddress has 4 parameters and it has 1 result. Taking a look at the parameters, what we see is makeAddress has the 4 parameters that we've identified. Note that static methods don't have a self parameter. A static method operates independent of any object instance. Hence, the idea of a self parameter makes no sense. It's not relevant for a static method. The user method results query is a little bit more interesting than what we saw previously. Here we again see getCity and compare indicated as returning built-in data types, and the result type owner for these rows is the null value. But given that address is not a built-in type, but a user-defined type that resides in the schema of Mo or is owned by Mo, we now see the result type owner column populated with a value other than null. An object type is a model of something that exists in the real world. When we interact with these real-world entities, what we find is there can sometimes be slightly different ways in which we can accomplish the same task. This leads to a very important concept in our software representation of these real-world entities. For example, it's possible that the same operation could be accomplished with different sets of input. The variations in the behavior can be captured in our representation through what's called overloading of methods. Let's consider, for an example, we have city as an attribute of our address object type. There might be 2 different ways to inspect the value of this attribute. Let's consider 2 versions of the getCity method that we might use to perform an inspection or an examination of the city. Consider that a city, as we've defined the attribute, is a character string. So getCity could simply return the value of that character string, the name of the city. But suppose cities also had associated with them some numeric value. For example, in the state of Connecticut, we have 169 tax towns. So each town then has an association in some way with a numeric value. So suppose getCity worked in a similar way. What we have is you call getCity, and instead of getting the name of the city, what is returned is the number of the city. So the idea is there's a slight difference, but effectively the same information is conveyed back to the user. So this is the concept, again, of overloading, because there would be 2 definitions, 2 methods with the same name. However, the interface would be different. So the 2 methods have the same name, but return something different or have a different signature in terms of what would be passed to them. So overloading requires either a difference in the parameters or the return values. Assuming we go with the idea of 2 versions of getCity, here's how we could define our type. We define our attributes. All of the other methods remain the same, but with respect to getCity, we have two variations here. One returns a character string, the other returns a number, but both are called getCity. Both are member functions. If we query the metadata, in particular user method results, to see what is returned by our methods, we see two instances of getCity, and again, the difference lies in what is returned, the type of thing returned by the methods. So the concept of overloading that you should be acquainted with from object-oriented software development, taking a Java or C++ course, for example, applies within a database in supporting object types. In this video, we began our discussion of object behavior. We introduced two data definition statements for declaring object types. The create type statement introduces the structure of the object type and announces what methods would be available. The create type body statement provides implementation details of these methods. We described four categories of methods: the constructor, comparison methods, which included map and order, member methods, and static methods. We also identified sources of metadata related to user-defined types or object types, something in addition to the SQL+ describe command. And finally, we explained the concept of method overloading. We'll continue our discussion of behavior in our next video. The emphasis will be placed upon user-defined constructors.